Sometime we may be interested in initializing the data members of a class when we create an instance of the class. So for example, different component may have a situation where each of the component require its own initialization of a data member. So that could be HGU with the help of a dunder methods which are present for a class. Dunder basically stands for double underscore method. So this basically stands for all the methods which are applicable for a classes and have double unders. So we'll understand how to use dunder method over here to perform initialization of the data member. So we proceed like this. We keep our data member as it is, that is A and B. Then we proceed and add def. So these are similar to the functions that we have discussed in Python fundamentals. But the difference being we need to now use two underscores. So you could see series of dunder functions eligible for the class. In fact, we could use dir method with a class to know the different methods that are applicable for the class. We'll proceed and use init. The first argument remain the self. We'll understand the meaning of this. After self, we could add the arguments to a init method to initialize different data members of a class. Let us assume we want to initialize both A and B while creating an instance of a class. Then we proceed like this. So to access variable A of a class or data member of a class, we need to use the keyword self dot A. This refer to a data member A of a class, and this will be updating with the value that user add to an argument A. So here we'll just add A. This will update whatever value that user provide to an argument A. Likewise, B will be updated with the B argument that user will provide while creating an instance of a class. So far, we have created an instance of a class like this, T1, then the class name, and we have added an empty parenthesis. So this empty parenthesis could have a multiple argument. From this, you could see A and B are the two argument now user need to provide. So if you just go ahead and try to execute the code, now you could see we are getting error in the same code which is working perfectly fine in our previous example. The primary reason being we have added now a custom constructor. So when we create an instance of the class, Python automatically add the constructor to a class, or in other word, it automatically assign the memory location for an instance of a class. In other language, for example, C++ or in system Verilog, we need to explicitly add a constructor to create an object of a class. But in Python, it is automatically done. To control the behavior of a class while creating an instance, we could use this init function. So when we specify an argument, these are an argument expected from an user. So if user do not provide an argument, it basically throw an error, and that is what we are getting over here. Initialization basically mean while creating an instance of a class, user need to provide A and B argument, which we are not doing over here. So we are creating an instance, but we are not providing a initial value for both A and B. Let us go ahead and add 5 and 2. So as soon as we add 5 and 2, A will be automatically updated with the value of 5. B will be automatically updated with a value of 2. That way, we can control initialization of a variable with the help of an init method. Let us proceed and try to access the values of A and B for an instance T1. So to access the value of an A for an instance T1, we proceed like this, T1.A. And if we try to execute the code, now code works fine because we have provided both the argument required for creating an instance of a class. And you could see the value of a data member in the class is 10. This represents our parent class. And from a parent class, we could create multiple child class. So here T1 represent the child class. And while creating a child class, we have added an initial value to be 5 and 2. This will update initial value of A and B for this class to 5 and 2 respectively. And for that reason, you could see a value of A for the child class T1 is 5. Likewise, if we try to print the value of B for the child class, it is 2. If we create a different instance, let us just go ahead and try to create a different instance T2 and with different value. Let us add a value as 55 and 60. So this will have different value for A and B. So child class could have a different value based on initialization that we do. If you wish to keep argument optional, then you could also initialize this to some known value while adding it to an init function. So that will make the argument optional. Let us just go ahead and remove both the arguments from T2. And now if we try to execute the code, we'll still able to execute the code without an argument. The primary reason being we have added the default value for A and B. So if user do not add any value to an argument specified, it will assume a default value. And for that reason, if the value of B is printed over here is 20, which is the default value for the argument. This way you could use an init function to provide an initialization to the data members of a class. Once you add the default value for an argument, it is not mandatory to specify the initial value for all the classes. As and when you require to add a different initial value for the data member, you could add the values to an argument and that will automatically update the initial value for data member.